Thank you, Kushali, and thank you all the researcher who has submitted your paper. Because see, even though it is a pandemic situation, but research progress must go ahead. And this conference is a testimony of the same thing. And I really appreciate all the researcher who has submitted the paper over here and contributing in the continuous progress of the research. So the first paper I would like to invite to present Ani Rajan and Ambuja Segankar. It is the title of the paper is Survey of NLP Resource in Low Resource Language, Nepali, Sindhi, and Konkani. So I think it's a survey paper. So let's start with the survey paper. Uh, yeah, over to presenters.
Yeah. Any Rajan? I'm unmuting you, but you are not responding.
Yeah, I am here. I am here.
Okay. Please go ahead with your presentation.
So I just open my paper and say share, no?
Yes.
Yeah, 1 second. Huh? I'll do that.
Any
yeah, 1 second, madam. One second. Yeah, because I stay in a remote area, no? I'm just putting up things.
Yes, yes. Please.
Yeah. And I didn't know where I was. That is why that was the whole problem. Where I should.
Oh, okay. No problem.
Yeah. Now
Within 1 minute, you should take.
Yeah. My presentation is just opening. 1 second.
Okay.
Meanwhile, I want to request Vivek Tiwari, Shailesh Gupta, and team to be ready for the next presentation of soybean crops non-beneficial insect identification using mask RCNN. So please be ready so we can save this arrangement time. Yeah, thank you.
Yeah. Presentation. Madam, my presentation is just opening. Huh? Just 1 second.
Okay.
Yeah. Yeah, now I say share, no? Madam?
No, I can't see anything.
Yeah. 1 second. Here I say share my screen, no?
No, ma'am.
Yeah. Can you see my screen?
No. Can we start with the second presentation?
Yes,
so meanwhile, Ani, you please be ready. Yeah. So I would like to Vivek Tiwari.
I think, sir, he is not there. So can I share? Can you see my screen?
Shailendra Gupta.
Yes.
Can you see my screen?
Yeah, you. Okay.
Can you see my screen?
Yes.
Yeah. Sir, I'll start.
Yes, please go ahead. Thank you.
Yeah. Yeah, my paper is on survey of NLP resources in low resource languages, Nepali, Sindhi, and Konkani. A presentation by Mrs. Ani Rajan and Dr. Ambuja Salgaonkar. Low resource languages are languages that are lacking large monolingual or parallel corpora, or we can say and manually crafted linguistic resources sufficient for building statistical natural language processing NLP application. Indian scenario of low resource languages, the development of NLP resources in small population Indian regional languages is a challenge. Now it is a challenge because the Indian languages are in phonetics, that means the way we hear, we write, and they have various scripts. Due to this multiplicity of scripts, collecting corpus is very difficult at times. Now, for example, like my work in Konkani, Konkani is a language which is having multiple scripts. You can write in Devanagari, you can write in Roman, you can write in Perso-Arabic, you can write in Malayalam, and also in Kannada. So now, which script to accept for digitization? Lack of text or speech corpus in digitized format. Now, if you look into some of these low resource language like Nepali, Sindhi, and Konkani, which I've taken from a survey study, you find that the speech corpus is very less what has been actually captured and digitized. Now, when I mean digitization, it means annotation of corpus. There is also lack of interest in annotation of corpus because these corpuses have to be annotated. For example, in annotation means I am a girl, so I is a pronoun. So this is called as annotation, giving some kind of a character or what it stands for in a sentence. And this is the scenario of low resource languages. They are facing these challenges. And in our new educational policy, it says that, or the national educational policy says that the lower education has to be, that is up to class 5th, has to be in the native language, I mean their mother tongue, in the language of the state. Then how are we going to have digital corpus to teach the students? So this is one of the challenges this low resource languages face. The objective of my research, of my paper is a comparative study of NLP research for Nepali, Sindhi, and Konkani languages. These languages are spoken by relatively small populations and they have low NLP resources. And the number of native speakers are falling. That is, the people who are speaking this language are reducing. Hence, the list of results presented here points to area where more research is necessary. So as in this paper, when I did study for my these 3 languages, when I did try to compare, I found that there is a lot of research scopes in these low resource languages. A simple comparison between these 3 languages: Nepali language, it is an Indo-European language. Sindhi language is an Indo-European and also Konkani. Official language of Nepal is
Sorry
Nepali.
for the interruption, ma'am.
Yes.
But you have last 2 minutes for your presentation.
Okay. Yeah, official language of Goa and 2.8 million Nepali speakers, Sindhi speakers 2.5 and Konkani 2.3. All 3 are a low resource language. Nepali language, you can see post tagging, sentiment analysis and NER work has been done using very basic algorithms like hidden Markov and SVM, support vector machines. Sindhi language also NLP work is very low. In Konkani, it's even less because NER, named entity recognition, is still not done. This is a comparative chart of some of the core topics in NLP, natural language processing, like part of speeching. There are only 6 papers in Nepali, 2 in Sindhi and 5 in Konkani. You can see like the serial number 6, translation. In Sindhi, nothing is there. In Konkani, nothing is there. Name entity recognition, Konkani, nothing is there. Transliteration, Nepali, you don't find any paper. WordNet, you don't find in Sindhi. Spelling checker, you don't find in Konkani. Word sense, disambiguation, you don't find in Sindhi. And Konkani, this work is not reported. Now, conclusion and future work is there is urgent need of attention to develop these languages towards NLP. The population of these languages are reducing because the younger generations are migrating to other countries and losing touch to their native language. Researchers have to explore these domains in NLP for low resource languages. Thank you.
Any question from audience?
No, sir.
Okay. So
Please give
it
your
was
feedback, sir, on this
it was survey paper,
presentation.
and why you have chosen Nepali, Sindhi, and Konkani? Only these three languages, or
Yeah.
what's the criteria you have selected to choose these three languages?
So my PhD work is on machine translation for Konkani language. So when I was trying to compare Konkani language with the other languages, I found that Konkani, Nepali and Sindhi are similar in the cross section of population and the work done. Because other few languages, like other role resource languages, have literally not done any work, many more, and some have done some extra, means more work. So these three languages I found, and as per some of the researchers in Konkani, in Goa, language researchers, they have told me that Konkani has some similarity to Nepali because this is one of the language which has come from the northern, and all of them are Indo-Aryan languages.
Okay. Uh, so now, after this survey, what's your plan for further research?
Yeah, now further research is like this I have just shown that the lacuna in each of these language where there are researchers can take up. And in Konkani language, I have already built a spelling checker, a stemmer, and a morphological analyzer, and a translator using Apertium.
Okay, so are you planning to design a generalized model, or you are going for a coded model for each of these language mentioned here?
So at present, for this for the translation and morphological analysis, I have used Apertium platform, and stemmer and spelling checker I have hard coded. I mean, I have coded using the data set of Konkani.
Okay, so can you why you are not making dynamic because you have already classified it as a low resource language.
Yes, sir. Yes,
Yeah,
sir.
so one classification you have already opted. So for all the similar kind of language, if you create the model in such a way that it means if you take the dictionary from each of the language in the desired format, and it can serve your purpose.
Yes, sir. At present, now if the dictionary is Konkani, it will work for Konkani spelling checker. If I get a dictionary in the same format with the paradigms in, let us say, Nepali, then it will work. It will work for any language.
Okay,
It is
so
language independent.
you can have a good paper related to the model framework for this.
Yeah, sir, it is a very simple framework. No complexity. Using Python and using a search algorithm, these are built.
Right. Okay. Thank you,
Yes,
Ani.
sir. Yeah,
Okay.
thank
Thank
you,
you.
sir. Thank you, sir.
So now I would like to invite Chinky Karda for the presenting paper soybean crop non-beneficial insect identification using mask CNN.
Chinky, if you are here, please chat me so I can unmute you and you can go ahead with your presentation. Sir, I think
Yeah, she is not there, I think.
yes, yes, yes. So we can announce our next presentation.
Farhin Rehman is
Fareen
there?
Rahman. Yes, sir. Yes, sir.
Okay,
I'm
so I would
unmuted.
like to invite Farhin Rehman to present his paper, a modified leach B protocol for energy aware Wi-Fi sensor network for efficient network lifetime.
Assalamualaikum. I'm Farin Rahman. Uh, is my is my presentation visible?
Yes, your visible. Your
Okay.
presentation is visible. Please
Okay.
go ahead.
May I start?
Yes, it will start. But you have
Oh,
only 5 to 6 minutes to
okay.
complete your presentation. Please stick on.
Okay. First of all, I want to say thanks for giving me the opportunity to present my work. This is my work, which is entitled as Modified Leach-Bay Protocol for Energy Aware Wireless Sensor Network for Efficient Network Lifetime. Uh, here, first
Can
of
you
all,
switch to the presentation mode, please? Thank you.
okay. First of all, it's me, Farin Rahman, who is the presenter and also the first author of the paper. And they are my co-authors, Maruf Hossain, Muhammad Sabir Hassan Shoha, Sejuddin Jaman, and Muhammad Rakibul Islam. Table of contents. First of all, I want to present the introduction, then the provision of the presentation, background of Leach algorithm and Leach B algorithm, proposed modified Leach algorithm, actually it's modified Leach B algorithm, and at last, the conclusion. Okay. Introduction of wireless sensor network. Here is a short brief about wireless sensor network. Actually, wireless sensor network is defined by the network of a particular specific region which uses wireless data connection, and in a wireless sensor network and in wireless sensor networking, sensor nodes are used, and these nodes and network nodes are generally implemented to uh, to observe the climate, to observe the environmental conditions like temperature, sound, pressure, etc., etc. And these nodes are actually working with using DC power supply. Node strength, autonomy, independency, etc., affected by the DC power supply. Okay, the power sources and batteries are not, but these DC power supplies are not suitable enough to ensure a network's healthy lifetime and autonomous operation. So the nodes, sometimes the nodes will die out very soon, and energy hole problem creates. So there needs some analysis of changing protocols of network formatting, which can sometimes ensure robustness of a network. Okay, provision of the presentation. First of all, basic introduction of wireless sensor network, which I have already presented. Then significance of Leach, and a comparison has been, I will show comparison of Leach and Leach B. Then introduction to proposed modified Leach B, which is the main objective of my work, and comparing this with two multi-hop application, two other multi-hop application specific protocols, which are cognitive leach and WST leach. WST stands for weighting spanning tree. Okay, and at last I will show the graphical representation of my the all protocols. Okay, first of all, the background of leach and leach B. Leach is low energy adaptive for clustering hierarchy, which is a noble clustering algorithm. Here, clustering strategy is the main strategy, and which will select cluster heads randomly. And sometimes it results the fluctuation of the number of cluster heads, and it ignores the node's residual energy. Actually, in Leach algorithm, the cluster head will be selected randomly just using time division multiple access protocol. So the cluster head selection will not be in a energy efficient way, and that's why the leach algorithm will be the leach algorithm has been modified, and after modification, Leach B is actually the modified version of Leach, in which cluster path, number of nodes, number of clusters, which are predetermined. Here we have seen a brief about Leach B, which is actually a modified version of Leach protocol, in which in Leach B, cluster path, number of nodes, number of clusters, and predetermined number of clusters, everything is actually predetermined, which is absent in Leach. Actually, Leach B forms clusters by using a distributed algorithm where nodes make yes sir.
May I request you to directly come to your contribution part, because time is limited, and in this way it would be difficult you to cover all the content.
Okay, sir. Definitely, sure, sir. First of all, I want to say something about Leach B, because my work is actually modification of Leach B. In Leach B, I have modified Leach protocol, where the number of cluster, the number of nodes, the number of sensor nodes, and the number of remaining sensor nodes, which is actually considered as non-cluster head nodes, are predetermined. And my work Okay, this is the threshold of Leach algorithm. I will not go in detail because time is limited. These are the threshold of Leach B where the time interval is limited. The residual energy E is actually the residual energy. The number of clusters NC is predetermined. The number of nodes NTOT divided by NC, which is considered as the sensor the number of sensor nodes, which is actually fixed, and this is the threshold equation, which is considered as which is actually the main factor in Leach. In Leach B, Leach B uses a threshold function TP like typical Leach, but uses different format of equation. And when when node actually use threshold equation, if the percentage will be less than the threshold equation, then the node will be selected as a cluster head, and if it is not, then it will not be considered as a cluster head. Okay. The threshold value is TP if the chosen number is less than the okay, less than the threshold value, the node P declares itself as a cluster head, and then when a node is selected as cluster head, it will send a notification message to the rest of the nodes. Non-cluster head nodes join the nearest cluster head of low energy. Okay. My work is a proposed modified Leach algorithm. I have come directly here. Actually, Leach B has some lackings, which is one of them is data aggregation, in which information expressed gathered in a summary form. It is considered as a disadvantage of Leach B. In Leach B, we have used a threshold equation, and that threshold equation will decide the node will be cluster head or not. Here we have presented another one threshold equation, and this threshold equation will decide the node will be cluster head or not more quickly than Leach B. Here I will show a graphical representation. Here we have here the x-axis shows the number of round, and the y-axis shows the number of alive nodes. Here this blue line represents yeah, sure. Yeah, ma'am.
Sorry for the interruption, madam, but you
Okay.
have last 1 minute to conclude your presentation.
Okay. In figure 1 for Leach protocol, node begins to die after 935 rounds, and after that, nodes of balanced Leach, I mean Leach B protocol, the node will die after 1158 rounds. Then the nodes of cognitive Leach, and after the nodes of WST Leach, the nodes of modified Leach protocol begin to die after a few more rounds of those of the previous all protocols. I mean, Leach my proposed Leach protocol has definitely better lifetime than the above all protocols, because it dies after few more rounds than the other protocols. And in my other graphical representations, this green line shows the graphical representation of my proposed Leach protocol, where the sensor node dies after the sensor node dies later than the previous protocols. So we can say sensor node has so I can say my modified Leach protocol has comparatively better lifetime than the Leach B, cognitive Leach, and WST Leach protocols. Okay, these all are the graphical representations which I have generated after doing MATLAB coding. This is a tabulation in which I have shown comparative analysis, and my modified Leach B protocol has very high lifetime than the other protocols. And in conclusion and future work, determination of location is kind of lacking in my work. So in future, I want to focus on location. I want to focus on a determination of location. Energy constraints like this should be considered at the time of choosing suitable protocol. and cluster head selection algorithm and data aggregation of which reduces the amount of communication. And in this paper, with the research of the LeachB protocol, a modification has been approached which is called modified LeachB, which provides better energy efficiency and longer network lifetime than LeachB. Thank you.
Any question from
No,
other
sir. No, sir.
audience?
Please give your feedback, sir.
Okay, so basically you have shown the output, but um, uh, can you show the can you give the small description about the exact research gap and how you have bridged that research gap to get this outcome?
Okay, I have some research gaps. First of all, I didn't solve the localization problems, and another one research gap is I've just done some MATLAB simulations, but I didn't do mathematical calculations, or I have shown a threshold
No,
equation.
my question is that through simulation it's okay, but in exactly what problem you have addressed in the simulation, so you got the better outcome.
Okay, I have shown energy efficiency problem because in Leach in Leach, actually the sensor nodes should the sensor nodes are chosen in a very inefficient way, but in LeachB, the sensor nodes are chosen in a very efficient way. And in my proposed work, in my modified LeachB protocol, the sensor nodes will be chosen in a more energy efficient way. Actually, the problem is energy efficiency, and I have tried to solve this problem so that the network lifetime will increase.
Okay, thank you.
Thank you, sir. Thank you, everyone.
Yeah, thank you.
Okay.
May I request Pratiksha Kanwar to present her paper on cognitive study of data mining techniques in educational data mining for higher education. Pratiksha.
Diksha, are you there? Sir, I think.
She is not there.
Yes.
Okay.
So we can
Shaima
proceed with
Uthman.
sir.
Shaima Uthman. Okay.
Yes.
So now I would like to invite Shaima Uthman to present paper titled Performance Improvement of Lossy Image Compression based on a polynomial curve fitting and vector quantization. Shaima, over to you.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Yeah.
The paper of title Performance Improvement of Lossy Image Compression based on Polynomial Curve Fitting and Vector Quantization, prepared by Teacher Assistant Shaima Osman, Dr. Abdul Latif Abu Laila, Dr. Amr Muhammad, and Dr. Zaki Nusir. And my agenda is starting by introduction, database, the proposed method, comparison with other research, and the reference. The introduction. Digital media is widely used nowadays. Each printed media can be converted to digital form. Consequently, this makes pressure on storage requirements as well as network bandwidth for multimedia storage and exchange. So, an image compression technique is proposed to reduce the size of digital images to save storage space, power, and transmission time. We start by the definition of polynomial fitting. Polynomial fitting is a new efficient method to compress images using polynomial curve fitting approximation technique is presented in this paper. The polynomial curve fitting represents many pixels by a smaller number of polynomial coefficients. The general polynomial curve fitting equation is P of x equal P naught plus P1x plus P2x power 2 to Pn minus 1 times x power n minus 1. My database is 6 images, 3 of gray, paper, and rice, and cameraman. The color, paper, Lena, and Kahraman. Of size 256 times 256. The proposed method. I start by read the input image, then transform the input image to one row. Then set a threshold value that depends on the value of the root mean square error. Then apply the first degree of the general polynomial curve fitting function as for the first segment, which is consists of 4 pixels of the image. Calculate the root mean square error, then check. If the root mean square error is lower than the threshold, I will write fitting segment. I will fit the segment. And apply the first degree of the general polynomial curve fitting function for the next 4 pixels after the fitting segment. Else, if the root mean square error is greater than the threshold, I will add pixels according to the increment value is constant equal 2 pixels, then apply the first degree of the general polynomial curve fitting function to the new segment. Then calculate the root mean square error. I repeat step 6 until finishing the full image and the coefficient matrix is formed. Then apply the vector quantization algorithm, LBG, on the coefficient matrix to get the reconstructed image. And finally, I calculate the measurement parameter, peak signal to noise ratio, compression ratio, root mean square error, and similarity structure. For the vector quantization algorithm LPG, the basic idea of this vector quantization is that if a group of representative image vectors known as code words can be designed, they can be used to represent all blocks of the image. The group of representation code words will form the code book. Generally, the vector quantization algorithm consists of 3 procedures: codebook design procedure, encoding, and decoding procedures. For the codebook design procedures, we start by dividing the input vector data, xi, from 1 to n into channel samples by using the minimum distance rule and store them in the matrix S of dimension n times m, as shown in equation 2. Then use the channel sample to determine the centroids of the Voronoi regions, and all the codebook are replaced by these centroids. Step 1 and step 2 are repeated until no other change happen to C. The encoding procedure. The index is created for the most appropriate representative code board, and this index is used to replace any arbitrary vector corresponding to each block in the test image. The matching process between the input training vector and the code word from the code book is achieved by using the minimum squared Euclidean distance, and the index table is created as a result of the encoding process. The final procedure is decoding. The code book, which is now part of the image representation, is employed to translate the index back to its corresponding code word. The size of the code book reduces the total size, and the compression ratio is enhanced, but with a slight decrease in peak signal to noise ratio. In the proposed method, we calculate the size of the reconstructed image using this formula. Size of the reconstructed image is equal number of coefficients times size of coefficients times length of the codebook plus size of an index times number of segments plus size of segment size and the number of the segments. The experimental result. From figure 1 and 2, we note that as CBS is increased, CR is slightly increased, and an improvement in peak signal to noise ratio is achieved. So the peak signal to noise ratio is directly proportional to the CBS.
Saima madam.
From table 1 and 2.
Saima madam. Hello.
Hello.
Ma'am, am I audible, ma'am?
Yes.
Yes. Ma'am, you have last 2 minutes. Please try to conclude your presentation on time. You have last 2 minutes, madam. Please try to conclude your presentation on time.
Okay. From table 1 and 2, it's not that the CBS is increased and the root mean square error is decreased and the similarity structure increased due to the improvement in peak signal to noise ratio. Experimentally, the proposed method achieves low root mean square error and high peak signal to noise ratio. Furthermore, the compression ratio is improved with a good similarity structure for gray and colored images. Also, we note that CBS has an effect on both CR and peak signal to noise ratio. The reason for this effect is that as CBS increases, the number of index increases and peak signal to noise ratio increases also with a slight increase in CR. From table 3 and table 4, we show the best compression ratio with an acceptable peak signal to noise ratio, root mean square error, and similarity structure for both gray and colored image, respectively, as CBS equal to 50. And this is the comparison to other research. Figure 3 and 4 and 5 compare the compression ratio, peak signal to noise ratio, and root mean square error within the current methods to the proposed method for gray and the current methods such as GVG polynomial surface and adaptive polynomial surface fit are applied to the same tested images. The proposed method has achieved a better compression ratio with high image quality and a low root mean square error compared to the other existing methods for all the testing gray and colored images. It's observed that the proposed method has achieved the result which is better than the other compression ratio. And this is the reference, and thank you. Any questions?
Yes.
I finished. Any questions?
Farik sir.
Hello.
Hello?
Yes, sir.
Hello.
Yes, sir.
Shaima, have you prepared a time-space diagram with comparison of the other algorithm for your algorithm for the compression activity?
I can't hear you, doctor. Can you repeat the questions?
Do you have time-space diagram of your proposed work algorithm and the other algorithm to compare the different performances, time-space diagram? Because you have compared the technical parameters, but at the same time, memory and processing, that parameter, have you compared with the other algorithm?
I compare the parameter of compression ratio, peak signal to noise ratio, and root mean square error, not the time.
Okay, thank you.
Okay. Not at all, thank you.
So now I would like to invite Joel as Bioge. She's present or?
I think, sir, we should move to our next presentation. He is not here.
Okay. So Rashmi JR.
Yes.
Rashmi JR is present?
Yes, sir.
Okay.
Yes.
So I would like to invite Rashmi JR to present the paper Global Random Walk for the prediction of mRNA disease associate using heterogeneous network.
Yeah.
Please.
Yeah, sir. Very good evening to all of you. Today I am presenting global random walk for the prediction of microRNA disease association using heterogeneous network. So my first slide goes, that is my research work is on microRNA. MicroRNAs are very tiny that is 18 to 20 nucleotides in length, and they are considered as post-transcription regulators, where this regulation plays an important role in causing diseases. Some of the microRNAs are called oncogenes and few others are called suppressors, depending upon the role played in the progression of diseases. This has necessitated the research for microRNA disease association as the experimental prediction is expensive. To complement it, computational approaches are designed, and this has here necessitated the computational approaches to come up, and lot of computational approaches have been designed in the past. There are different types of methods have been designed. They are categorized into computational approach based on the similarity, and some of them are machine learning methods. And talking about my method, I'll present now the materials and methods. And here I have used, one is functional similarity score for microRNAs, which has been downloaded from a paper which has been proposed by Wang et al. And the matrix is denoted by MSS, that is functional similarity matrix, functional similarity microRNA. And microRNA similarity based on environmental factors is calculated by using the equation here. MEFS, that is modified environmental factor similarity. That is, we are going to calculate this environmental factor similarity that we have collected it from the database, that is environmental factor database. And here, based on that, we are extracting the matrix. I don't want to go into the depth because we are lacking the time and I have to cover all the aspects. And similar way, we also calculate the microRNA similarity based on disease also. And disease semantic similarity is calculated as proposed by Van Gietal's method. And we also take one more matrix called as the probability matrix that is taken into account by human microRNA disease association matrix. It is an adjacency matrix. If there is an association between a disease and a microRNA, then it is considered as 1, otherwise it will be a 0. Here, talking about the workflow, I'll show my the workflow here. Yeah, workflow. Here I have taken 3 matrices. First, microRNA functional similarity matrix, microRNA similarity based on environmental factor, microRNA similarity based on diseases, and we have taken a maximum similarity with the help of these 3 matrices. And then we have taken disease semantic similarity, and we have column normalized both the matrices. And we have one more probability matrix, which I told you previously, that is a adjacency matrix. The adjacency matrix is taken, along with that adjacencies transpose is also taken. Here our method comes into the picture. My method is basically a random walk method. Here I am doing a random walk from microRNA to disease and disease to microRNA. Here we will calculate first the initial probability vector. Initial probability vector is calculated. So usually in normal random walk, what we do is we take into account only that is adjacency matrix while calculating the initial probability vector. But here we have calculated extra feature or enhancement is, we can call it, we have calculated the Laplacian score for the disease and also for the microRNA, so that it helps in enhancing the results. And with this, we will be able to predict the disease microRNA for all the diseases simultaneously. And we have the parameters are alpha and gamma in our this one. And we have this I is termed as the identity matrix, and this NMSS is a normalized microRNA similarity matrix, and this is a normalized adjacency matrix. And we have taken yeah, hello,
sorry for the interruption, but you have last 2 minutes for your presentation.
Yeah, fine, thank you. I'll finish off. I'll wind it off in that. Okay, we have done random walk from the microRNA disease and disease to microRNA. Both random walk scores we get it, and those scores have been integrated to get the results. That is the collective scores we'll take into account for the prediction of microRNA and the prediction of microRNAs associated with diseases here. So results we have calculated for some 8 to 9 diseases. The results are encouraging. We were able to predict out of 50 microRNAs for ovarian cancer, we were able to predict 49, and stomach cancer 48 microRNAs, and breast cancer 46, lung cancer 47, pancreatic cancer 47, leukemia 44, kidney cancer 40, and brain cancer 39. We were able to predict. That is out of top 50 microRNAs. These are the confirmed microRNAs. And regarding the parameter setting, here restart parameter for a random walk, we have set the different parameters, that is from 0.9 to 0.8, 0.7, 0.6. And the best results we were able to get for 0.1, that is we got the area under curve for 0.91, which is considered as the best. And we have compared our method with some previously only 2 methods we were able to compare. In future, I'd like to compare it with still many methods so that we can prove our method is a better one. And here, talking about the contribution, this global random walk can predict microRNA for isolated diseases, means diseases which do not have previously any association, and does not require any negative training samples as in a machine learning method. Even though a lot of methods have been designed, each and every method have a drawback. In future, we can enhance the, what we call it as the accuracy of our method by adding few more data, that is we can go for microRNA family information and microRNA target information, so that we have plans to enhance the results by adding these few more data into our method. And these are the references which have been used for our paper. Thank you.
Yeah.
Yeah.
Hello.
Yeah, sir.
Here I just wanted to suggest you that there are a standard way to present the results and comparison and all these things, because like if you go to the slide where you have shown that out of 50 how many, so it should be in the terms of percentage, so it can be directly compared. Okay, because see, by looking your table, it is not mentioned even in the table that it is out of 50. When you given the detail, then only it means we come to know. So when you prepare the presentation, it should be self-explanatory, and at the same time, what I found that it means for microRNA, you have presented random walk, right? But as compared to the other algorithms, there are parameters which can be compared. So that is, I think here it is not in depth, so that you can improve.
Yeah, sir. Yeah, sure.
Okay. Okay. Thank you.
Thank you. Thank you, sir.
Now, I think previously Joel as Baigoi not present, but now he is available. So I would like to invite
sir, sorry for the interruption. He is available, but he is not able to adjust in his system. So we'll put him in a last presentation. Okay. So now we are announcing about our next presentation.
Yeah, Varghese. Josie Elsa Varghese is present.
Yes, sir. Yes, sir.
Okay. So she is going to present a paper, a pilot study in software-defined networking using Wireshark for analyzing network parameters to detect DDoS attacks. Please go ahead.
Am I audible, sir?
Yeah, perfectly audible.
Yeah, thank you. Thank you. Good evening, one and all. Myself, Josie Elsa Varghese, research scholar under Dr. Balachandra, the professor and the head of the Department of Information and Communication Technology, MIT Manipal. Here we are going. Here I'm going to present you a pilot study in software networking using Wireshark analyzing network parameters to detect. So this is all the agendas. So about introduction, you all know that nowadays the cyber criminal activity is increasing day by day. So it is among all the cyber activity, the DDO is having a prominent role, and we can see that in February 2020 also the largest strike has happened on the AWS, and in 2018 February, GitHub also be stricken by 1.3 terabytes, so on. So how can we mitigate this? So detection power has to increase. That is the key point we have to be focused when we have, even though there is so many of technologies now prevailing against the DDoS attack, still this is happening in our in our society, like DDoS attack, that its prominence is increasing. So it can be reduced by detecting by increasing the detection power. The detection power is nothing but it is the ability in which how fast a DDoS attack can be detected without overwhelming the network configuration. So we are choosing SDN. SDN is nothing but a new novel architecture, network architecture to design, build, and operate the network. Here we can see that it is broadly classified into 3 different layers. One is the forwarding layer, second is the control layer, and the third is the application layer, where we are taking a static way of computer network to a dynamic, agile, and scalable and innovative way of network architecture. Here the main beauty of this SDN architecture is the centralized SDN controller, where all the network intelligence is resides. It offers a global view of the network. So the programmability of can be easily done through that, and we can manage it also. So my title is, I already discussed, it is a pilot study. It's only a preliminary study in software-defined networking using Wireshark for analyzing the network parameters to detect the DDoS attack. So objectives is nothing but it's a pilot study for analyzing the significance of the network parameters which can affect in the DDoS, which can helpful for detecting the DDoS attack. And second is to recommend a high-level architecture for the fast DDoS detection in the SDN environment. So motivation is, as I am going to implement DDoS detection in SDN network, as I already told that it having the advantage of a centralized controller, that is acts like a drawback also for the DDoS attack, because a single point failure will happen due to the DDoS attack. That is a major concern regarding this. And moreover, the detection of the DDoS is very complex, and because of its disguising nature. Moreover, the lack of the efficient framework for the DDoS detection and the SDN network. As we know that DDoS detection is a distributed character, at the same time the SDN having a centralized character. This two nature is discordant with each other. And the importance of analyzing network parameters in both normal and attack scenario to build a lightweight DDoS detection system, since lightweight system is more preferred for the SDN framework. So literature survey. Swami is presented a survey regarding the DDoS defense mechanism in SDN environment, where he explained regarding the discordant nature of this centralized controller and the distributed denial of service attack. And we are concluded into two alternatives to find out a better solution for the DDoS detection framework. One is to incorporate or collaborate the data plane layer for the DDoS detection in the SDN controller, as SDN network. Since in the SDN network, the data plane is act like a dumb switches. It's having only a forwarding. It only acts like a forwarding devices. So if we collaborate that to data plane to the DDoS detection, it will reduce the channel congestion, channel overhead, and overloading of the SDN controller, so that we can avoid the bottleneck. And the second option is like we can introduce a lightweight statistical anomaly detection algorithm, where we can where in statistical anomaly detection we can use we can detect the detection with minimum number of features, and it is faster, and of course it is low demand for memory space and the CPU utilization. It also improves the response time, and it lowers the overhead of the SDN controller, and then can be able to detect both the low and high rate of attacks and even the new attacks. So system architecture. So here we did a case study with using the 6 node and using the POS controller and using Wireshark as the network analyzer. So the result. So we are analyzing the network parameters. First, the network parameter is a time sequence graph, where in the normal scenario we can see an exponential graph. Where in the attack scenario we can it increases in an exponential manner. Suddenly it goes to a steep manner. And in normal scenario, window scaling also happen in an exponential manner. But in attack scenario, we observe that it is started with the exponential manner, suddenly it will be increased its window scaling factor, and after the attack is happening, it advertises the zero window since the receive buffer is full. And again, round trip time. It is we can see that there is no overlapping in the normal scenario, but there is definitely so much of overlapping happen in the attack scenario. The throughput also, in the throughput in the Mbps rate. This is a comparison which I already showed in, in the picture. So high level architecture. This high level architecture is nothing but where we can incorporate the detection parameter in the data plane itself. So here my suggestion is that like if we incorporate the DPDK is nothing but it's a data plane development kit. If we incorporate that, it having the high efficiency apart from the flexibility. So we can be, if we do the packet capturing using DPDK, it will increase the efficiency of the detection system also. So we can extract the network parameter for the statistical anomaly detection in the data plane itself, and only the anomaly mitigation has to happen in the control plane. The overhead can be reduced. So the conclusion is like this case study shows a significance of network parameters in identifying the DDoS attack, and it concludes with a high-level conceptual model for the better performance of the detection of the DDoS attack. And as future scope is designed, a prototype, the designed prototype model will be implemented in a data link layer of the SDN architecture with a changing baseline according to the time series. And this defense framework is able to detect the DDoS attack with high efficiency and low overhead due to the collaboration of the DPDK framework in SDN environment. Thank you. This is all about reference. So.
Thank you for presenting such a nice paper, and I appreciate your approach and the way you have presented. You have followed the guideline like citation and the way it should be presented. I found it is a good one. Thank you.
Thank you, sir. Thank you.
So I think now only one paper is remaining, right? Joel, are you ready with the system to present your paper? Joel? Hello? Am I audible? Yeah. Please present your paper.
Mute. Okay. Hi. I was actually. Can you hear me? Can everyone hear me?
Yeah, you are perfectly audible. Go ahead.
Okay. I was telling the conference host that my supervisor is struggling to access the link, and he actually would like to watch the presentation. So I'm trying to help him get access. I don't know if you wouldn't mind giving me 1 minute for that, would that be fine? Is that going to make us late?
Please do hurry up.
Okay, sure. Thank you.
Joel, are you there?
Hello.
Yes, Joy.
Yes, I was speaking now with the doctor. He said I can have 1 minute to just put my supervisor in.
Yes, yes, yes. You have, sir.
Okay. Okay.
Mr. Jola, everything is okay?
I'm still communicating with him. Just 1 minute getting in. Sorry for the inconvenience. Okay. We are still 13 here, still not here. Okay.
You please start. Meanwhile, maybe he will join.
Okay. Yeah, I can also do that. Okay. And anyway, it is recorded, so yeah, he should be able to take it on.
Well, please start your presentation.
Okay. Okay. Let me share. Okay. Can everyone see?
Yes, your screen is visible, sir. Please go ahead with your presentation.
Okay. Yes. Okay. Hi everyone. My name is Joel Scientific Bioga. Am I audible?
Yes, yes, you are audible.
Okay. Thank you very much. My name is Joel Scientific Bioga. I'm from CPUT in South Africa, and I am a doctorate candidate supervised by Dr. Balden Vipin, who's also in CPUT, South Africa, head of telecommunication program. I'm going to present this paper on comprehensive survey of existing researches on NOMA-based integrated satellite terrestrial network for 5G. Okay, through this presentation, I will quickly give you the problem background, then give a brief description of NOMA and integrated satellite terrestrial network concept. Then I will briefly discuss the type of radio access network studies, and then give a survey of NOMA-based ESTN studies. And based on the survey, I will give you the observations and the open research topics that have been identified, and then close with the references. Okay, well, A radio access network is actually a network in which an access point grants the access to a user to utilize the resources, frequency, and power of the network. And mobile access network, generally mobile radio network, obviously where the link between the access point and the user is wireless in most times. And the most common ones is what we call cellular network, that is the terrestrial mobile radio access network. And we also have the satellite networks, which is also another type of mobile radio access networks. And recently, studies have tried to, have thought of merging the two to have integrated terrestrial satellite networks. So generally mobile radio access network are evaluated by the capacity, latency, reliability, which include quality of service and the fairness, and the coverage, how far they can go geographically. And over the past 4 decades, we have had 4 generations of radio access networks. First, the 1G, the 2G, the 3G, and the 4G, which is...
Joel, you have only 5 minutes to present the paper, so please manage accordingly.
Sure. Okay, so yeah, so then we have the 4G, which is mainly based on orthogonal multiple access. But now the new services that we want to implement in the telecommunication, like smart grid and industrial internet, require massive connectivity, and therefore 4G becomes sort of a limit. So we now have to get to 5G. And in 5G, basically, the technologies that are proposed include NOMA, millimeter wave, MIMO, and the satellite, the integration of satellite and terrestrial networks. And yeah, there has been a lot of work going on the utilization of NOMA for 5G, on terrestrial, on satellite, and recently on integrated. But in terms of integrated, we have not managed to see any paper that gives a review of existing work. And that is what this paper is actually doing, is just giving a review of existing work on NOMA application to integrated satellite terrestrial networks. So briefly, what is NOMA? The figure 2.8 just gives a geographical illustration of NOMA. In OMA, we have one frequency slot, which is on which we serve one user. And in NOMA, we serve more than one user in one frequency slot. That's basically it. And in frequency, in power domain, this is what it looks like in figure 2B, whereby 2 users will share the same frequency and just differentiate each other by power. And that would be what we call power domain. NOMA. It can also be code domain NOMA, which the difference will be in code domain. But in this presentation, we focus more on the power domain because that is what most of our work is on globally. And in terms of integrated satellite terrestrial networks, figure 3A gives a cooperative integrated satellite terrestrial, whereby the satellite and terrestrial components can access the users interactively. And the cognitive radio is also whereby the satellite and terrestrial can access the same user at the same time. Well, when we talk about the studies to be done, generally network design include the design of multiple access encoder. And here we focus on the pattern matrix design, which generally is the precoding algorithm if we want to have beamformings, and resource matrix block design, which is the power allocation algorithm. And there is also what you call user clustering to select which user should be served with who in the network. And in terms of system analysis, network analysis generally include outage probability, ergodic capacity, secrecy rate, And the studies that are presented actually are on these different studies. So this is the survey of what we have identified from the existing work in terms of NOMA-based cooperative integrated satellite terrestrial networks studies. So Yan et al. In 2018 investigated the performance of NOMA-based cooperative ESTN, in which the satellite serves as a satellite and the terrestrial serves the same user, but the terrestrial uses a relay. Okay, and then in SCI 2019 investigated the impact of amplitude and forward and detect and forward relay. So this table basically presents, I'm not going to cite all of them individually, but this table presents the different studies that have been done for analyzing integrated satellite terrestrial cooperative networks. Okay, in terms of design, we've seen that the actual design, be it power allocation design or precoding design for such systems, has not been reported. And in the table 3, we have a summary of NOMA-based cognitive radio ESTN studies. Okay, and we have Zhu et al. Most of the studies have presented have focused on the cognitive radio underlay mode, and whereby the NOMA, non-orthogonal multiple access, is used for the terrestrial component and not on the satellite components. And they et al. Designed a precoding algorithm for the system based on the maximum minimum fairness optimization concept. And Lin et al. Also designed a precoding algorithm based on the iterative penalty function. Yeah, if we go through the table at the end, we've got Jaya et al. In 2019 that also designed a cognitive radio overlay system whereby both satellite and terrestrial uses NOMA, beamforming, and multicasting. And the technique was to use advantage of power and frequency domains. So these are the few studies that exist in terms of integrated satellite terrestrial networks design. And our observation are that the field is relatively new, because very few works done so far. In terms of system analysis, most research so far on the field investigating the performance of cooperative ESTNs. The system, okay, the analysis done consider both perfect and imperfect channel state information, but very little attention has been given to physical layer analysis in this context, and no reported performance analysis of cognitive radio ESTN's design. Yeah. So in terms of the system design, most identified research focused on cognitive radio design, and the reported studies here present a combined algorithm for both terrestrial and satellite network, combined power allocation algorithm. In terms of precoding algorithm, some studies present combined, other studies do separate precoding algorithms. But in all power allocation, that is very interesting. In all power allocation design, the studies focus on maximizing system capacity, and no study actually speak of fairness. Yeah, that's and most of the studies that have been covered assume perfect physical layers, so no physical layer impairments, so perfect SCI, no channel impairment, complete IC cancellation, which is not realistic. So based on these observations, the research topic that we have managed to bring out is that more investigation should be done in terms of the analysis of a system with more than 2 users per beam, both in terrestrial and satellite networks, to increase the system capacity.
Please conclude.
This is actually the conclusion. More investigation of the system design for fairness, because fairness is one of the requirements of 5G, because we don't want to have one user being too much catered for and other users not being catered for at all. And yeah, consider channel impairments, imperfect channel state information, imperfect IC cancellation when doing the design. And yeah, and from other studies, from other papers, these are additional research topics that they are also highlighted, like and at all, the moving satellite beams is a problem because low orbit satellites do not have fixed beam on the ground, like geostationary orbit satellites. And then also the effect of imperfect CSI on the SIG brings more error, so it should be looked at. Yeah, so that's basically what we got from the review. And here are our references. Yeah, thank you.
Thank you. It was nice paper presented by Joel. I think Kushali, can we conclude, or is there any other paper remaining?
No, sir. We haven't any paper for presentation.
Yeah, someone wrote in the chat box, Dipen Patel, that he's ready with the paper ID 806, but I think it should be in the another track.
Yes, sir. It is.
Okay. Yeah. Thank you.
Yes, sir. Yes. Thank you. Thank you so much. Thank you, sir. Thank you, all of you. Thank you for your presentation. The chat box is open. The chat box is open. If anybody have question, they can ask directly to the presentee or to the host or co-host. I sincerely thank our researcher for their excellent presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates, payment receipts, and thank you letter through mail within 2 working days. Further, all the papers have already forwarded to the Springer for publication process. The publication will be live within 4 to 5 months. Kindly cooperate with the team of ICTCS during this tenure. I also thank you, Dr. Satyen Parekh, for chair this session. Thank you so much, sir. Thank you for your valuable appearance.
Thank you. In fact, it was my pleasure to chair the session, and some of the paper was really in-depth, and it means they did hard work. And I hope that the other researchers who are just buddy researchers and presenting first time or second time their paper, they got idea from the it means good papers. Thank you.
Thank you, sir. Thank you so much for your appearance. It is very meaningful for us. I also thank to our participants. Stay safe, because precaution is always better than cure. Stay healthy. Dr. Satyen Parekh, this is small greetings from us to you. Thank you so much. Thank you so much for your appearance, sir. It is mean a lot. It is mean a lot, sir.
Thank you. Bye.
Thank you. Oh, before you are going, before all of you are leave the meeting, I would like to announce that please open your camera. So we can take a glimpse of this ICTCS 2020